Right, here in 4.4, it's kind of a continuation of, or they're looking to rational functions. If you remember the last section, we were looking at asymptotes and whether they had horizontal or oblique asymptotes. The same thing's going to continue here with the ultimate kind of end as graphing. And they ask for some things along the way, which is, I guess, good to look at. In terms of asking questions and stuff. So we'll do some examples together. So the first question that I want to look at with you, sorry about not having the right pen there, just back that out of there and get something. The first question I'd like to look at with you is the rational function, and it comes pre-factored for us in this case. Now some of them will and some of them will not, and what they're asking for is for you in like a part A, I guess. If it's not fully factored, they want you to fully factor it, not reduce it at all, but just fully factor it. So let's start with the first question. What's the domain? Hopefully by now you're good with the domain. The domain is almost everything except what makes the bottom 0. And so what makes the bottom 0 is 0 and -8. Sorry, I almost put a positive there. That's our domain. They'd like to know the X-intercepts, right? Or what we call the zero. Sorry to pause there. Well, X-intercepts are where the top 0. And so the X-intercept is just 1, x equals -5. So it's going to cross the x-axis at x equals -5. Now, I said something there, but I don't necessarily know. Is it going to cross or touch? Let's look at the multiplicity. So the multiplicity of the x plus 5 is, it's a multiplicity of 1. I'll do mult 1. Therefore, it's going to cross. And that's important for us to know. So some of the same information, in fact, all of the same information that we had in the previous section. Does it have a vertical asymptote? And the answer is yes. I have domain restrictions that I can't get rid of. So we're going to have a vertical asymptote at x equals 0, and we're going to have a vertical asymptote of x equals -8. I think if you go back, I misspoke. We have a vertical asymptote along the line x equals 0, and we have a vertical asymptote along the line of x equals -8. Okay, we can't cross those at all. Now, here's what I want to tell you, because they're going to ask you about this next. Vertical asymptotes behave just like zeros in the sense that they have multiplicity. So the multiplicity of the x equals 0 vertical asymptote is 1, right? And if that didn't make sense, why? Let's look at where it's coming from. I'll use this kind of light blue line. It's coming from right here. And that has a power of 1 on it. So that's why I'm saying it has a multiplicity of 1. Very similarly, x equals -8 also has a multiplicity of 1. So why does that matter? It means that it switches. Okay, so what happens on a vertical asymptote? Let me just draw a general one. I'm going to put it in red so it stands out. I said I was going to put it in red and then I didn't choose the red. Okay. And so here it is in red coming in here, right? This vertical asymptote that the line cannot cross, or the graph cannot cross. If it has multiplicity of 1, or odd, if it has odd multiplicity, then if it's going to positive infinity on this side of it, because remember, vertical asymptotes are where the graph just explodes, because essentially the top's staying the same, but the bottom's getting closer and closer to 0. And if you take the same number and divide it by a smaller and smaller number, it's going to get huge. So if it's going to positive infinity on the left of it, then it's absolutely going to go to negative infinity on the right. Vice versa too. If you found that it was below the x-axis down here, then it must be going to the negative infinity. But if it's multiplicity 1, then it's going to switch. And they're going to ask a question kind of like that. They're going to say it's infinity on one side and negative infinity on the other. And I wanted you to know what that meant. So because they both have multiplicity 1, let me get an eraser in here and erase some things that I added here. So because they had a multiplicity of 1, it's going to be negative infinity on one side and infinity on the other. They're not naming the sides. That's up to the graph. You'll do that in just a moment. You put all the pieces together, but I wanted that to make sense. So if a vertical asymptote has a squared on it, then it's going to be on the same side. If it's going to stay positive, right? It's not going to cross that x-axis. It's going to stay on the other side. And I guess that's a really good way to put it so that it's in line with the other terms that we use, either cross or touch. Okay, so let's go to part D. And they're going to do this on all the problems. I don't think I assigned too many, but who knows, maybe it does seem like too many in the end, but the exposure, it helps, and the types of problems are different each time, and you'll see that as I choose different ones. So what about this? A horizontal asymptote. Does it have a horizontal asymptote? Well, let's look at the degree. The degree of the top is 1. Hopefully you see that the degree of the bottom is 2, that if you multiplied it out, it would be an x squared. That means the degree of the bottom is bigger, or the degree of the top is smaller than the degree of the bottom. And so, yes, you have a horizontal asymptote of y equals 0. Okay. And then E, an oblique asymptote? No. None. Right? It has horizontal, it can't have oblique. Those are obliques where you have to do some extra work. They might ask this question too. Where does the graph cross the horizontal asymptote? So if it has one, they might ask, where does it cross it? Well, let's take a look. The horizontal asymptote is y equals 0. Remember, our original equation is r of x is equal to x plus 5 all over x times x plus 8. And so what we would wonder is, could this ever be 0? So could 0 equal x plus 5 all over x times x plus 8? And when we solve for it, we realize, oh yeah, it can, right? Because we're multiplying both sides by the bottom. 0 times anything is 0. Move over the 5. Yeah, at negative 5. But we already knew that because we said it had an x-intercept at negative 5. So of course it's crossing. Are we concerned that it's crossing a horizontal asymptote? Absolutely not. Because horizontal asymptotes are for large behavior, for large values of x. It's for end behavior. Okay. And so let's go ahead and graph it. Now they may ask you, where's the graph above and below? So if I were you, I would graph it by hand first before answering this question. Above the x-axis. Well, maybe that's all they're asked. Well, I don't know. We're going to have to graph it using everything that we know. So what do we know? If I start to graph this graph right up here, and we take some of the information that we have, let me come right in here. I think we can do this. So we have a 0, negative 5, negative 8 that make a difference. So here's our coordinate axis. I'm going to get rid of some things. So we know our domain, right? So that's gone. X-intercept of negative 5, and it's going to cross. 1, 2, 3, 4, 5. It's going to cross right there. It has an x-intercept. So I've used this information. So you may be tempted to put something in a graphing calculator. You really don't want to do that because what they're trying to get you to do is use information to make choices. And yes, you could take an easy way out of putting it in a graphing calculator and saying, ta-da. Note that if we were in that in-class setting, there would be no calculators being used on the exam. I would structure the exam where that wouldn't be needed, and this would absolutely be a problem where that wouldn't be needed. So be careful about using a calculator. Let's get the vertical asymptotes in there. I'll put them in red. One is right here at x equals 0, and the other is right here at x equals negative 8. And what we need to do is find out where we are. Now all we need is 1 point. Okay, so let's talk about how to do that. My advice to students is pick something really big. Well, actually, we don't have to pick something really big. Actually, maybe we're a little bit ahead of ourselves. Let's get that horizontal asymptote in there. I forgot that we had a horizontal. So before I start figuring out where I am, I like to get all my asymptotes in there. Here's where it's crossing that horizontal asymptote because of, we already knew that because of the 5, but it's not going to cross out here. So let's talk for just a minute. Okay, so we get this horizontal asymptote, no oblique asymptote, and so we're getting all of this information to help us out. So I'm erasing this just to show, hey, we use this stuff. And now let's come up to the top. The only thing left down here is where is the graph above the x-axis, and we're about to answer that question. So I just want you to plug in a number, any number you want, that is on the positive x. Some positive x. I'm just picking something out here. So this graph has 3 regions. I'm going to label them from left to right. Area region 1, region 2, region 3. See, the sad part is you're probably going to be matching a graph. And so as we were doing this in class, it's very common for at least 1 or 2 people in the class to just not even put something in a region. You need to have a picture of that graph everywhere because the domain is all reals except at -8 and 0, which is kind of shown. So let's pick something in region 3 that I labeled. Let's pick just a positive x. How about 5? You could care less what the actual value is. You just care whether it's positive or negative. So let's look at r of 5. r of 5 would be 5 plus 5 all over 5 times 5 plus 8. And my only question to you is it positive or negative? And that's 10 over 5 times 13. I mean, you can do this. It's a waste of your time. Is this thing positive or negative? Well, it's positive. So you can start graphing it. What do you know? You know that next to it's in the positive place, and you know we're not crossing anywhere else. Otherwise, we would have picked up another x-intercept, but we only had one, -5. So you are positive in this whole region, and you know you're going to be coming down towards the horizontal asymptote of 0. That's it. Because, remember what this asymptote is right here. I'll put it in red. This is the asymptote x equals 0. X equals 0 comes from that x right there in the problem. It has multiplicity 1. So a question that you answered earlier, or that we answered together earlier, was that you would switch sides. So you know you're going down to -infinity there. And you must be coming up in some fashion here to this point, and then must be continuing up. Because no matter what, if it's a vertical asymptote, it goes to infinity. So we got to get up there. So we don't know exactly how that line bends. You'll have a nice matching thing there. You're just looking for some line that would go down to -infinity on the left-hand side of 0, come up and pass through -5, and then shoot up to -8. And then just remember, because the x equals 8, right? That's where we're at here. We're at x equals -8. Because that had multiplicity 1, we are definitely on the other side of it. And so we're down at -infinity here, coming up towards that axis. And that's the graph you're looking for. You could check yourself. You could pick something beyond -8. If I pick something beyond -8, let's say -9. -9 plus 5, a negative number, all over -9 times -9 plus 8. Well, that's 3 negatives. 3 negatives make a negative. Of course we're below the x-axis. So where are we above the x-axis? So if the question is, hey, where are we above the x-axis? I would use the graph to help me out there. And so that for that question F, I would come back, right? Because we're not come back. I guess we're doing this on the side. But I would say, oh, it's above the x-axis from -8. Can't include it because it's not part of the domain, all the way to 5. And if it says truly above the x-axis, it's not above the x-axis, at -5, sorry, at -5. We got that portion, and then we also have the portion from 0 to infinity. Those are the two regions that it's above the x-axis. Pretty nice. You're going to be doing this type of work over and over and over again. So what could it look like? Well, here's another example. Example number 2. Same questions, right? H of x is equal to x squared minus 19x minus 20 all over x plus 5. So the first thing that they're going to ask you to do is factor it if it's not factored. And very quickly you're going to put, you're going to put x minus 20, right? If this is taking you more than just a couple of seconds, you really need to be better at factoring. You will not pass subsequent classes. They think they're being nice when they do this. So there's a re-representation of h of x. Now what does that help us do? That helps us see the domain. The domain is a set of all x's such that x does not equal negative 5. It helps us see the x-intercepts. The x-intercepts are negative 1 and positive 20. It helps us to know whether it crosses or touches. It crosses and crosses, right? Because it's multiplicity 1. It helps us to see vertical asymptotes. We have one vertical asymptote. X equals negative 5 is a vertical asymptote. And therefore, we know that it's negative infinity on one side and infinity on the other. Okay, because the multiplicity is 1. Again, if the multiplicity was 2, we would say it's going up to the same infinity on each side, right? No matter which side you're on, it's going in the same direction. Horizontal asymptote, well, that's a degree comparison. We get a horizontal if the degree of the bottom is the same or bigger, or conversely if the degree of the top is the same or less. But in this case, the degree of the top is 2 and the degree of the bottom is 1, so there's no horizontal asymptote. But unfortunately, there is an oblique asymptote, which is why I chose it. And the oblique asymptote is, we got to go find. We got to go do long division. So for the oblique asymptote, yes, there is an oblique asymptote, but we got to go find it. So we got to take x plus 5 into x squared minus 19x minus 20. So we got to say, oh, okay, that's x squared plus 5x. We got to subtract. Let me get in here and subtract. Right, this long division that you first learned in beginning algebra, and subtract this one, and so we know what we get out of that. We get negative 24x, and so I know how to get that, and I'll bring down the 20. That's minus 24, and we're done. As soon as we match that guy, just making sure we did that right? Who cares? I'm going to put that. Who cares what negative 24 times 5 is? And you could use a calculator, I guess, but again, we know that the remainder doesn't matter. What matters is that we get some number here that x can't go in. You know you're done at that point. And so, oblique asymptote, absolutely we have an oblique asymptote. What is it? It's y is equal to x minus 24. So you can have some oblique asymptotes in there, which is good. Expect them on the exam, type of thing. Okay, so we have an oblique asymptote coming through. What else are they going to ask? They might ask something like this. In fact, I know they do. Where does the graph cross the oblique asymptote? And you're going to have to do some work. You're going to have to set the y's equal to each other. You want to know, where does h of x, right, that you can see right up here, and y cross? Well, let's find out. I think it's easiest to use the top version there. So the question is, you have two things. You have y equals x minus 24, and you have h of x equaling x squared minus 19x minus 20 all over x plus 5. So where are you? You're setting two equations. Well, you're solving a system of two nonlinear equations, which you've done earlier in this class. We'll do it by substitution. We'll just let the y's equal to each other. So hopefully you know h of x is just y. And I mean, that's what's been taught to us from the very beginning, that the function symbol is a replacement for y. And so this is the question. Where does x minus 24 equal x squared minus 19x minus 20 all over x plus 5? Well, we just solve it. You know what to do. You multiply both sides by x plus 5. And you go through the work. Right? No magic there. Are you going to have to do this type of algebra? Yes. Are you going to have to do it a lot in calculus? Absolutely. So that is what makes calculus hard. It is not the calculus concept that makes it hard. It is the algebra mess that's created in the process. So you know what this is. This is x squared minus 24x plus 5x minus, I am going to have to figure out what 24 times 5 is. So 5 times 4 is 20. 5 times 20 is 100. Okay, right? So 120, right? Coming through there. And again, you're welcome to use a calculator in that process. I'm not restricting that at all because I feel like if I do, somebody will use it. And that's not cool. So we might as well let everybody use it. And that's equaling x squared minus 19x minus 20, right? We want to know where those two are equal to each other. Let's clean it up. That's x squared minus 19x minus 120 is equal to x squared minus 19x minus 20. Well, if we bring our x squareds together, they cancel. Our 19x's together, they cancel. And so we end up with negative 120 needs to be equal to negative 20. And so there is no solution. They do not cross. Right? So this is just a wonderful application that's midstream in all of this. Now, why do we care? We care because we need to know sometimes when those oblique asymptotes are crossed for some application stuff. Usually that's pretty specific to an engineering type of thing, but we want everybody to be prepared for whatever they may be getting into, right? And so we care where horizontal asymptotes are crossed and all of that. Calculus makes it maybe easier to identify, maybe not in this case. But all that work is to say it doesn't cross, right? So where does it cross? They don't. But is that work good? Yeah. Because it's very representative of the algebra that you're going to do. They don't. Okay, awesome. So, perfect. Now what are some of our other questions? Oh, where's the graph above the x-axis? Where is it below the x-axis? And the graph. Well, let's go get the graph. Look at all this great information we have in order to graph it. Okay, so what's our graph look like? Let's see what we remember. Remember what we do. We use this first part with the the x-intercepts and the vertical asymptotes. So the x-intercepts are negative 1 and 20. Okay, so way out here it's crossing. And negative 1 it's crossing. And we have a vertical asymptote somewhere, so I put that in red just to remind myself that I can't cross it. It's at negative 5. So interesting. Let me calculate 2, 3, 4, 5. And we got something red over there. And now we have an oblique asymptote. Remember what our oblique asymptote is. Y is equal to x minus 24. You know all about that, right? Because you've been through pre-algebra. Right? That's where we learn about graphing that as a pre-algebra class. So way down here at negative 24 it's crossing, and it's up 1 over 1. And so we have this oblique asymptote. And I'll do my best to draw it. right? Just coming right up like that and going on forever. Now, I may not have drawn it perfectly, but I did my best. Okay. Okay, so what do we know? Well, let's figure out where we are. Let's plug in 0. If we plug in 0, and the best place to look at that is right here. If you plug in 0, that will tell us everything that we need to know. If you plug in 0, you get a negative number, you get a negative 20, times a positive 1, divided by a positive 5. Well, I know that that's negative 4. We can figure that out. Doesn't matter. What matters is that it's negative. So when you plugged in 0, it was negative 4, meaning it's right here. So the graph's going right through there. And you know it's not crossing this guy right here. So we know that it's making this connection and coming up to this vertical asymptote. We also know that it's not, the graph's got to come over here and it's got to follow this line. But it can't bend up like this or we get another intercept. So what must be happening here is it must be somehow turning, coming through here and coming down like this. Okay, a little bit strange in that regard, but does seem to be where it's happening. Do we have any y-intercepts? I didn't look for y-intercepts. So if we let x be 0, yeah, we get the y-intercept of negative 4. Right? Oh, apologize. We just found it. It has just that single y-intercept. So very interesting that it has that single y-intercept right there, and then needs to come to this line, the x minus 24 line. So what must be happening is it's coming, if I did not have the right pencil coming through there, and here at negative 1. So what must be happening in this is definitely got to be coming up like this, and because it crosses through here. And then it must be bending off of that guy in order to come down to this line. Okay, it probably does not go through that again because we don't pick up another y-intercept, and it can't follow it the other way because we would pick up another x-intercept. What's happening out here, it's got to be crossing. So this is an oblique asymptote. I don't know if we can use the same multiplicity rules for that. So we need to figure out where we are maybe when we plug in something that's very close to 24. Positive 20. So what if we plugged in 19? If we looked at h of 19, what would we have? We'd have negative 1 times 20 and 19 over 24. We would be negative. So we must be coming from down here, right? Eventually coming off of that mark, coming through here, and then eventually following this line. Now, your graphs aren't going to be perfect. They're sketches. And so what's happening over here? Well, we must be negative down here. The only way for us to be down here and not pick up an axis, and this is going to shoot down that way to pick up that vertex. And yeah, that would make sense too. It would have to be on the other side because the multiplicity of the only vertical asymptote is 1, and so it's got to be on the other side, and then it would naturally go down, somehow bend and then come back down to meet this line, never crossing it. So the graphs can get a little bit weird. We don't absolutely know. A graphing calculator could help you see that in the end, but it's good to just struggle through it and just see what the lines look like and talk about where it's above the x-axis and stuff. So that's the work that we're looking at. They're not all terrible. There's even ones like this. We'll do one last one, see what we can do pretty quickly. And this is all explained pretty well in the book. I looked at the examples and they were decent. So, I mean, here's what we would find out of here. We would find that we had an x-intercept of 0 and 1. The multiplicity is 1 for the 0, so it's going to cross. And at 1, it's going to touch. We would find out that it has a vertical asymptote. And the vertical asymptote is x equals -4. And because it has odd multiplicity, it's going to be negative infinity on one side, infinity on the other. Okay. That would be work so well in order for us to graph it, but we should find out if it has a horizontal asymptote or oblique. Look at the degrees. They're the same. The top is a degree 3, right? If you multiplied out the x squared and ran through the x, you're going to have an x cubed. If you multiplied out the bottom, you're going to have an x cubed. And so they match, and so it's a y equals a ratio of the leading coefficients, which would be 1 over 1. And so we start to build this graph, and that's what I would recommend you do. Don't be constrained by how my math lab is asking you the questions. Get this picture going. Go in here and say, oh, it's crossing at 0 and it's crossing at 1. I'm going to make these a little bit farther out. It has a vertical asymptote at -4. Okay, and so we'll come in here. Let me make that red. And we'll come right down here and we'll put a line. And go back to black and we'll extend this one out. Okay, perfect. That's what we know. Awesome. It has a horizontal asymptote of 1. Okay, so here we are up at 1. I'm going to go right across here. So remember, it can cross this line. Let's find out if it does. Is there a point where this function is equal to 1? So I'm going to just write off to the side here, x times x minus 1 squared all over x plus 4 cubed is equal to 1. So that's x times x minus 1 squared. Could that ever equal x plus 4 cubed? Well, I don't know. We have to figure that out. I don't think I left myself enough space, but they're asking that type of question. So we'd have to multiply that out. So I'll do that down here. X times x squared, minus 2x plus 1 is equal to x squared plus 8x plus 16 times x plus 4. And that's x cubed minus 2x squared plus x. Is that ever equal to x cubed plus 4x squared plus 8x squared plus 32x plus 16x plus 64? So does x cubed minus 2x squared plus x ever equal x cubed plus 12x squared plus 48x plus 64? Well, let's see. X cubes would go away, right? So if I bring everything over to the right-hand side, I'd have 0 is equal to, x cubes would cancel, 14x squared plus 47x plus 64. And that would be the question. Does that ever equal 0? Well, let's take a look. I don't know too much about that. What if we tried to see if it did by plugging in by using the Pythagorean Theorem, -47 plus or minus the square root of 47 squared minus 4 times 14 times 64 all over 2 times 14, right? So we just want to see where that's at, and the answers could be pretty nasty. So let me look at 47 squared minus 4 times 14 times 64. Okay, if you looked at that, this part right here is negative. That's what I was wondering about. Would it be positive or negative? And it's going to be negative. The 4 times 14 times 64 trumps the 47 squared. It's bigger than it. And we actually have a negative 1375. So the answer is no, they don't cross. This thing never crosses the line y equals 1. That's good to know, right? And so the reason why it's good to know is it kind of tells us the height of anything that goes above this. So let's talk for a minute. I don't even think you need to plug in a point to know what's going on here, and let me tell you why. You know for large values of x, you get really close to the horizontal asymptote, which in this case is 1. So let's come here. That means something. That means we're getting really close to 1 as we go out, and we know we're not crossing it, which means we have to be coming down to this guy. And let's talk about what happens at 1. Do we touch or do we cross? Well, it says we touch, right? So we must be touching right there, coming up, crossing through, and heading right down here. Okay, so there's some kind of little bump in between these two zeros, but we're heading down. Well, the multiplicity of the bottom thing is 1, so we know that we're going to be on the other side, what's written off on the right-hand side. I said the thing, but it should be the vertical asymptote. So we know for sure that we're up here and coming down like this. And we could check ourselves. We could plug in something like -5, and what you're going to get is a negative on the top and a negative on the bottom, which makes it a positive. So of course we're up there. We know that we're never touching this y equals 1 line because of the work we did down below. So it's pretty nice. All those things combined to 1. So I know this is a very long video, and the problems will take a little bit of time, but it is the longest section that you'll run across, this one and the previous one. The other work that we're going to do to wrap up for is not as lengthy, but very insightful.